So now you can open your VirtualBox, ma'am.
Yes.
Is it open? Okay.
Yeah.
Any disk is not updating to me actually. Okay, I'm sending you
Me
the.
again you have.
Just a second. Yeah. Fine. So where is your data? Here, I think so.
What's
In the downloads. So you have Trinity, you have FastQC, RSIM is there. I think we didn't install it, right?
yeah.
Okay, we can extract it here. Assembly stats is also, I think, not installed. Extract here. Okay, I will check one more thing. Okay, you have R3.4. Okay, so today basically what we will do, first we will run the Trinity. Okay, and then we will do the other thing. So first I will do the globalization for the Trinity. Okay, so for the globalization means you can access the Trinity from anywhere. So for that I have to open this bash.bash rc file, and I will type here sudo gedit slash etc slash bash dot, give your password. So this bash.bash rc file is very sensitive, ma'am. I think I already told you earlier as well. So what you have to do, you have to scroll this down. Can you scroll this down, please?
Yeah. Yes. Is it?
Basically, what I will do, type here export dollar, and I will copy this. It got stuck. What? Are you able to see any cursor on your screen?
No.
No, right? I think I am disconnected. Yeah.
It is there.
No, no, I'm
Yeah.
disconnected.
Yeah.
Now what I will do, I will do the globalization of the Trinity, as well as I will do the globalization of the assembly stats. So we have to copy the path of the folder. Okay, copy the path, and I'm just going to paste it here. Same way I will copy the path and I will paste the path of assembly stats as well. Where is assembly stats? Okay. Same way I have to do for the RSM, ma'am. Okay. Equals to dollar path and so I will copy this. And I will save all these things. And I will close this script. And I will also close the terminals. The older terminal every time. Okay. Now what I will do, I will open this script here. I will open your script and I will also open my commands. Okay. And I will tell you basically what we are going to do here. So yesterday, if you remember, we checked the quality of the raw data. We did the trimming and cleaning of the raw data, right?
Yes.
Today,
Yeah.
what we are going to do, we are going to create the assembly. Okay. Or you can say that because it is a de novo data, so we are not having any assembled transcriptome or reference transcriptome, right? So with the
Mm.
help of the sample data, first we are going to create the assembled transcriptome. Okay. So here you can see that how many number of the samples you have, ma'am?
Mm.
Two, right? So control and treated. So with the help of the control and treated samples, what we are going to do, we are going to create the assembled transcriptome. Okay. So yeah. So next step I can write down in your script transcriptome assembly. Okay. So in the transcriptome assembly, you have few steps, ma'am. You can say that the step number A. Okay. First, what you have to do, you have to concatenate all the samples together. So, any idea what is the concatenation?
Okay. Yeah.
Hmm. Okay. Concatenation means, ma'am, in the Linux, maybe you learned this command, the cat command, right?
Mm.
So what we are going to do, we are going to use the cat command, right? Then I will give you a control sample name, which is control1 dot fastq, right? Then what I will do, I will give you treated sample name, which is treated. It is capital T, right? Treated one dot fastq. So I am using, ma'am, your real sample. Okay, I'm not using your clean sample. But in the real time data, what you can do, you can use your clean sample because our sample is already clean. just to showing you I cleaned it again, right? To show you how you can remove the adapter. So that is why I'm not using it. But in real time, if you are going to clean the data, so you have to use that sample. Okay. Hello.
Yes.
Okay. So maybe you can take a note for this thing. And whatever you find important, ma'am, you can take the note because in the manual nothing is explained in this way. Okay.
Yes.
Then what I will do, I will give the output file name as a all.fastq. So I can remember all my samples are merged here together. Maybe if you have 4 samples, 5 samples, 6 sample, 8 sample, whatever number of the samples you have, ma'am, you have to merge all the samples together. Okay.
Mm.
So now your command is ready. Can you open the terminal and try to run this command?
Yeah. That is to merge all samples, this command.
Right, correct.
So here we have to write file name.
Correct.
First control one, treated one. Then
Yeah.
this symbol.
This is
But
your
here
output
two,
file name.
but that two symbols are necessary. Greater than two symbols are required here.
Greater than 2 symbols also, ma'am. It is actually nothing. It is just for the append. If you will give the 1 also, it will work. Fine.
Okay. And then on
Hello? Hello?
hello.
Yes, ma'am. Your voice is breaking. Can you repeat, please?
Yeah, I was saying that in this.
Hello? Hello, ma'am.
Hello.
Yes, ma'am. Your voice is not coming at all. Now, can you repeat, please?
Now,
Now it is fine.
now is it all audible?
Yeah, it is audible. Yeah, please tell me.
Yeah, I was asking that here we have mentioned all dot fast queue. So this
Hmm.
is our output file. In this
Correct.
file, we are going to merge both
Yeah, that means in file,
samples.
whatever
That's why.
numbers of the samples you are going to give here, right? One, two, three,
Hmm.
4, all the samples are now inside this file together.
Okay.
Okay? Yeah.
Okay. Hmm. And cat is for command is for merging. Hmm.
Yeah, for merging, or if I will tell you correct terms, it is the concatenation.
Yeah.
Okay? So,
No
ma'am,
such
actually,
file.
yeah, because you can see you are not inside the folder. Just see the path of your terminal, right?
Mm-hmm.
Close this terminal. Open from your data folder. Open it from your data folder. Close it from here.
Yeah. So from this folder,
Yeah, now go
where
here. Go inside this folder. De novo RNAC. No, no, no. Close it. Go inside de novo RNAC.
hmm. Hmm.
Hmm. You are not.
Now I have to open terminal.
Click on the right side of your mouse first. Now open it
Opening
up.
terminal.
Right.
Okay.
Now paste the command here and enter. Now check in your file. Do you have any command file name all.fastq? Fine.
Okay, delay control. All fast talk to this.
Right. So now the next step is what, ma'am? I'm going to convert this FASTQ sequence into the FASTA format. I will tell you one thing before. It is not necessary to convert the FASTQ file into the FASTA. Okay? If you are going to take the fast queue, at that time also trinity is going to be work, and if you are going to take the faster sequence, at that time also trinity is going to be work. But some client will ask, so that is why it is a just extra step which is I'm going to show you right now. Okay, so
Mm.
basically for converting the fastq file into the fasta, what I will do, why I'm not able to access this one. Can you scroll? Okay, fine. See here I gave you the link, right, of this website. Okay. Here
Yes.
actually they are providing you how you can convert the fastq sequence into the FASTA. And if you wanted to check into the internet as well, you can check from here as well. You can go with the web browser. You can open the new tab.
Mm.
I can close this. And here you can type fastq into. So now you can see that it is showing you so many links, ma'am, right? But
Mm.
maybe somebody is telling you with the tool, somebody is telling with you have to do with the help of something else, right? But if you will scroll this down little bit more, see, this is actually that website link. They are telling you with the help of the command line how you can convert the fastq into the fast one. Okay. So what I did actually, I copied the command from here. Okay. After copying the command, what I did, I pasted it here in your commands. Okay. That the step number B. Okay. Conversion of fastq file into fast. I am typing down in the bracket. It is not necessary. Okay. So you can remember it is not necessary. It is just for your understanding. So basically what you can see that ma'am, it is telling to you paste, right? After the paste it
Yes.
is telling to you des dash and file.fq. That means whatever file in the fastq format you wanted to convert, you have to give that file. So I wanted to convert my all.fastq, so I give that name. Then what they are telling to you, cut minus F, you have to forcefully cut the first and second line. Why the first and second line? If you notice in the FASTA format what you have the sequence ID and the description, and in the second line you have the sequence, correct?
Yes.
Yes. Same thing if you will notice here in the read what we have, ma'am. See if I will open your read. Head control 1.fastq. See, this is also the first two line. If I will take these two first line, this is also the FASTA format, right?
Yes.
So they are telling to you, you have to cut the first two lines, okay? What you have to do, you have to replace the at the rate symbol of the sequence with the greater than symbol, okay? And then tr command means for what? Every sequence you have to start with the new line. That means first you have to press the tab button and then new line. And then you have to store the result with the name of the file.fa. So I'm going to store it with the name of the all.fasta. Fine. So now can you do this thing as well? Can you try the conversion?
Yes.
Mhm.
Then, so copy. I have to run this command in terminal.
Yeah, you can just copy and paste it into the command line. It will run.
But now, command terminal I have to open from this
No,
folder or what?
just see, ma'am, just a second. Just see, already you have one open terminal here.
Here, here I think. Mm.
And enter. Now just check inside your folder. You have one FASTA file now. Right? So I will
Yes,
show
all
you how.
that first.
Yeah, just a second. So I will show you how your FASTA file look like now. Head all dot file. See?
Mm.
Correct. Now what we are going to do, the next command is, ma'am. The next command is here.
Can
We
you
are,
repeat this previous command? This.
yeah, just a second. What you have
Mm.
to do, you have to paste your, what you are, what are you doing, ma'am?
No, I'm not doing
Just,
anything with it.
okay. I
It's
think you
actually
close the script. I think you are moving your cursor here and there because I'm
no,
not.
actually it is there only. I'm not moving.
See, I can see that, right? De novo.
Yeah, but I'm not doing actually.
Okay, I don't know
Yes.
then. Okay, just leave the mouse. I will try to handle your system.
Yeah.
Okay. So basically, what you can do from here. Hmm. We took the ma'am all dot fast queue, right?
Mm.
We took all the sequences which is merged into the first file. We cut the first two lines from that file, right? From every sequence, we replaced the at the rate symbol with the greater than symbol, and then we added the sequence inside this all dot fasta file.
Their
Okay,
first line was ID, sequence
right.
ID, but second line was sequence, right?
Correct.
So,
That is why we cut these two first line, ma'am, right? And added in our file. See,
but
you
that,
have the four lines here, but we
mm,
required only first two lines, right? That is why we cut these first two lines only.
okay, so we have taken these two lines, that's why. Okay,
Right. So from
okay,
every sequence we are taking the first two lines.
okay.
Okay?
Mm,
Yeah.
mm.
Okay. Then I will move with the next part. So in the next part you have to generate the transcriptome assembly. So I'm not going to make this command for you. I will guide you and you are going to make it. Okay? I'm just going to copy this command. So this is actually the whole command. So I told you Trinity is what? Trinity is actually the assembler. Okay? And how
Mm.
this assembler is going to be work? It is going to be generate the transcriptome assembly for you. Okay? So transcriptome assembly. So I pasted the command here. Now I'm going to explain to you here. Here you
Mm.
can see that, ma'am, this is actually the path of my system. Home,
Mm.
Origin, Downloads, Trinity folder, and inside the Trinity folder, and if you will go, you will check there. We have one script by the name of the Trinity. Okay. So see. Here I am inside the downloads. What I am going to do, I will open this downloads here. Okay. This is your Trinity folder.
Hmm.
Inside this Trinity folder, I am having this Trinity. Right?
Yes.
Can you copy the path of this Trinity?
Yes.
Hmm. Copy?
Yeah. Here. Test.
No, no.
Yeah.
Just go
There.
with
There.
the touchpad.
Yeah.
Hmm. Here what you have to do, you have to
Hmm.
replace this path, right? My path with your path. Paste it
Okay.
here. Hmm. Fine. Now what you can see that ma'am, after this path what I gave minus minus sequence type. That means whatever sequence I am going to use for the assembly, right? What is the sequence type? Right? So it is in the
Hmm.
FASTA format. That is why it is written here FA. If it is in the FASTQ format, at that time what you can type FQ.
Okay.
Okay. Now ma'am,
Hmm.
the second thing is your data is single, and that is why I am typing here minus minus single. Okay. And if your
Okay.
data is paired end, okay, at that time what you have to do, I will tell you. Hmm. So if I will scroll this down. See ma'am, if your data is the paired end data, right? At that time you have two files, right? One is the reverse sequence, one is the forward sequence, right?
Right.
So you have to give the option like this, minus minus left and minus minus right. Okay.
Okay. Hmm.
Now see, after this what you have to do, you have to give the path of your merged file here. Okay, all.fasta file. So can you give the path of the all.fasta file here, and you can replace my path?
Yes.
Yeah, please try. Done. Now you can
Done.
see that because my data is the single end data, right? That is
Hmm.
why I'm telling to you here SS library type is the forward. Okay, because I have only one sequence. But
Hmm.
if you have two sequences at that time, what you have to do? One is the reverse sequencing, one is the forward sequencing file, right? That
Hmm.
is why you have to type here RF. Okay.
But that is on the reverse file. If RF is there.
No, no, one is the reverse, ma'am. If you will type R, that means reverse, F means forward. Correct?
Okay. Reverse
So,
forward. Okay.
right? Fine.
Hmm.
Then after that, what you have to do, ma'am, see here, the maximum memory I am telling to you 2 GB I am giving in my system. But we will check how much memory you have. So I will go with the settings,
Hmm.
and I will check from here you gave 3.8 GB RAM, right? So
Hmm.
what we can do, we can also use your 3 GB RAM here. So I can go with the 3G. Then CPU in my system, I have the two CPUs, I use the two, but in your system, you don't have the two CPUs. See, here you have only one CPU.
Hmm.
Whatever number of the CPUs you have, ma'am, after the, you can say that the multiply symbol, the number of the CPU is written here.
Okay.
Okay. So you have
Mm.
one CPU, that is why no number is given here. So what I will do, I will just go with the one CPU. Then the next thing is what, ma'am? This output. So here you can see that this is also my path, but
Yeah.
remember this trinity is actually having to give the output by its own name only. Okay. So you have to create one folder here by the name of the trinity. Okay. Output, it should be having the name of the trinity. If it doesn't have the name of the trinity is not
Mm.
going to give you the output. Okay,
Okay.
so you can copy the path of this as well
Here.
and paste it here. Fine, now your command is ready, ma'am. So now
Mm.
can you try to run it?
Yes.
Paste. See, your trinity is running, so we will wait just, and we will wait it is not throwing any error, and then I will explain you how this trinity is basically working. Okay.
Error.
Error, could not find the bow tie or bow tie to build. You don't have the bow tie. Yeah, but that day I told you to install the bow tie too, right?
Yeah, we have done actually that time.
Why it is not
You
showing?
also, yeah, you showed actually that time.
Okay, please give your pass. I will check the rest of the other tools as well. Okay. So the next tool is required is SAM tools. I'm not able to type. Can you type, please?
Yeah. Sam tools.
Right. And enter. Okay, it is there. Jellyfish.
Yes. Okay.
Enter. Fine. Now close this, ma'am.
Terminal. Okay.
Yeah, close the terminal because you installed the bow tie, right? So close it and reopen the new terminal from the same folder.
From the this.
Yeah, from the de novo RNA seq data folder.
Okay.
No, no, no. First you have to go inside. Yeah. Now open the terminal. Click on the
Mm.
right side of the mouse.
Mm.
Open in terminal. Paste your, copy the command of the trinity and paste. Oh, sorry.
So I think I'll show you.
No, no, just a second. I will tell you, ma'am. Don't
Okay.
go like this.
Mm.
You just click on this drop down key. See here.
Okay. So I will copy this command, right?
Yeah, copy this. So see, it is starting to give you the percentage, right? When the trinity is starting to give you the percentage, that means it is successfully executing. Okay.
Can you tell me about Trinity? Like how it is going to
Yeah,
assemble?
just a second, ma'am. I'm telling to you. Just give me a minute. Hello. Hello.
Yes.
Yeah. So now you can see that, ma'am, it is done. Now I will explain you how Trinity is working. So you are able to see my cursor, right?
Yes.
Why it is not going upwards? Okay, fine. Now it is working. Hmm. So actually Trinity is having, ma'am, total 3 stages. Okay. With the help of these 3 stages, it is what trying to do. It is trying to generate the assembly for you. And shall I make it big? Just a second.
Mm.
So first thing is what? First, what is the stage of this trinity? I will show you. See, this is actually the 3 stages of the trinity. It is totally 4, but it is initially they are telling the 3 stages. The first stage, or you can say that the zero status stage is jellyfish, and what this jellyfish tool is doing for the trinity, it is extracting and count the k-mers for you. So I wanted to ask you, ma'am, do you have any idea what is this k-mers?
Gamers.
Mm-hmm.
No, don't
No,
know.
okay. So for example, suppose, ma'am, you have the data, but the data is into the read format, correct?
Hmm. Hmm.
Huh. So now you can see that from here basically what is happening. Um, So suppose ma'am this is your read. Shall I switch the sides because here I have some problem to draw, I don't know. Okay. When you are able to see my screen, just tell me.
Yes.
So suppose see ma'am, this is your read. Okay. In this read, basically you have the sequence like this, right? ATGC, 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 something like that. Now what is this K-mers? K-mers are actually the short nucleotide sequences. Okay. For example, if I will tell you 7 mers, so this means they are taking the 7 nucleotide bases. Okay. If I am telling to you it is 8 mers, so they are taking the 8 nucleotide sequences. Okay. So first thing what Trinity is doing, first thing the Trinity is doing the extraction of the K-mers. Okay. And by default the Trinity is going to be extract 25 size of the K-mers. That means it is going to be extract the K-mer with the size of the 25 nucleotide base pair from the reads. Okay. And what it will do, first it will extract the first 25 nucleotide base pairs. Okay. Then it will leave out the first one, then it will go for the next 25, then it will leave out the two, then it will go for the next 25. Likewise it will try to cover the complete read with the 25 nucleotide bases. Okay. So this is called actually K-mer extraction. Now, the next stage of the trinity is what? After the extraction of the K-mer, the next thing you have here is, okay, now, yeah, inchworm. Okay, so what this inchworm will doing for you, you can see that assembly initial context by greedily extending sequence with most abundant K-mers. That means whatever K-mers are expressing in your data, right? If you will take a look of this diagram, this is your rate. It is extracted the K-mers from here, right?
Mm.
After the extraction of the K-mers, it is checking which sequence are actually most abundant. Most abundant means, ma'am, for example, if my sequence is this one, what is the next sequence which is able to cover the next of my other sequence? That means after leaving out my one sequence, what is the next sequence which is covering the most of the part of my sequence? Okay, that is known as the abundance, and that abundance is actually done for with the help of the inchworm is going to check for that thing for you. Okay, then the next thing you can see that this Silas what it will do, this abundance is check, right? After this Silas it is going to check for you what all are the overlapping contexts. That means whatever context you have, those contexts are how overlapped to each other. They are overlapped to each other more or they are overlapped to each other less. Okay. And with the help of this overlapping, it will try to create the graph for you. That means what it will do, because it is not like that. In that case, you have only one read. You have lakhs of the reads, right, ma'am? So what it will do, it will take the one read, it will take the second read. For every read, it will check, right? Whatever Kmer is present there, how much percentage overlapping is done. On the basis of the overlapping, right? Whatever sequence is doing the more overlapping. For example, here you can see that it is your sequence ATGGAA, right? Then after this you can notice the sequence is same TGGAAGT, right? Then after this sequence is similar GAAGTC, right? After this sequence is similar. That means they are doing the overlapping of the each other, right?
Mm.
And what it will do with the help of that overlapping region, it will try to create the sequence for you. Okay, and this overlapping, with the help of the overlapping, we will try to generate the graph. It is known as the de Bourgeois graph. Okay, then the next thing is what? The next tool, it is going to be used for you, the butterfly tool. Okay, what this butterfly tool will do for you, it will check everywhere because you have lack of the transcript, right? So it will check whatever overlapping region you received, correct? How those overlapping regions are covering your sequence. They are covering the more sequence or they are covering the less sequence. Okay, and on the basis of the coverage, it will cluster all the sequences together and it will try to create the assembled transcriptome for you. Okay, ma'am?
Okay.
Okay. So now you can see that if you will focus on this trinity result, and if I will scroll this down, see, basically what it is telling to you, trinity assemblies are written to inside the home Kalyani downloads de novo RNA-seq Trinity output trinity.pasta. That means inside your Trinity output, so many files are generated. Okay, but your main result is, or your assembled transcriptome is actually here inside this file. Okay,
Okay. Hmm.
so now let's check, do you have the trinity.pasta here or not? So see, this is your Trinity output. I will go inside this file. I will open this file here. See, here so many log files are here, but this is your trinity.pasta file, or you can say that your assembled transcriptome. Okay, and if you wanted to see how it look like, so you can go inside the Trinity output folder first. So I can use the cd command, so I can change my directory. And then what I will do, I will type down here head trinity dot pasta and enter. See, so how it is showing you your transcript, that means how many sequence it assembled, and it is try to generate your transcript. Okay,
So these are
now
different assembled transcripts.
right,
Those
ma'am, correct.
different length.
So now after this, how we will check how many sequence it used for the our transcript generation, right? So that means we have to check the statics, correct? And for checking the statics, we are going to use one another tool which is known as the assembly stats. Okay, so we already downloaded the assembly stats, but we didn't install it. Okay, so first we will install it as well. So I think it is step number 5. Yeah. Checking the statics of the assembly. So how we are going to check the statics of the assembly? With the help of the assembly stats. So now you can see that first what you have to do, first you have to call the assembly stats. Okay. After that, for which sequence you wanted to check the statics? You wanted to check the statics for the trinity.fasta file. Okay. But trinity.fasta file is where it is inside the trinity output, right? That
Yes.
means here what you have to do, ma'am, you have to paste the path of this file. Okay.
Hmm.
And then you can generate the output by any name. So for example, here we are generating it with the name of the assembly statics.txt file. Okay. So now first what you have to do, but before that you have to install the assembly stat. And these are the few steps to install the assembly stat. So can you try to install it?
Yeah. So stepwise I have to run these commands.
Yeah,
Yes.
correct. So first you have to go inside that, right? Inside the assembly stat folder.
Assembly
Go
stat.
inside the assembly stat folder, open the terminal from there.
Yeah. Assembly stat was in.
Yeah, it is the same way, ma'am.
Same. Right. So now open the terminal.
Right?
And
Yeah.
these
The step which is
commands.
written in my commands that you can copy.
These commands, right? First this
Right.
mkdir build.
You don't have the
Almost
CMake, first copy it and install the CMake first. Yeah, now you can run that command. No, CMake, ma'am. First run CMake because it is
okay,
not.
run. Okay, yes. This
Second one. First one.
First. Not the second.
Okay. Yeah, now it's second. Then you can go with the next one.
Next, make is done. So, make test.
Right. And enter. Now the last.
So go make instant.
So now you can see that it is telling to you the assembly state is already there inside your user local bin assembly stacks, right?
Yes.
So now basically what you can do, if you wanted to check it is installed or not, you can just simply copy this word assembly stacks. Okay.
Hmm.
Not able to copy, maybe you can copy and paste it in your terminal and just do the enter. See, it is showing you the manual of the assembly stack. It is installed. Now you can close both the terminals and open the new terminal. Okay. Open the new terminal from your folder, ma'am. From
Ah,
your de novo data folder.
from this folder.
Right. New terminal. Huh. Now what you have to do, you have to make the command for the assembly step, right? So in my script, this command is according to my thing, but here you have to do the few changes as I told you, right?
Yes.
So we will go with this option de novo rnaseq.sh, right? Enter. I will paste the command here. So you have to give the path of this file here, right? From the Trinity output folder, if you remember, right? I showed you where you have this pasta file. So go copy the path from there and paste it here.
From Trinity output file.
Right, correct. Go inside the Trinity output.
Trinity.fasta.
Right. Now your command is ready, ma'am. First save this script, right? Now copy the command and run into the terminal.
This is our output file. This.
Yeah, this is your output file which is going to be generated in your de novo folder. Just a second, ma'am. I will close one extra terminal for you first. Just a second. I don't know, I'm not able to click anywhere. Are you able to click? So you can close it maybe.
That previous one, which is not that I have to close.
This one, this second one you have to close.
Yeah, I
Fine.
have to
Now you
open
can.
this. Huh.
Yeah, this is fine.
Hmm.
And your connection is again resetted. Now enter. So, ma'am,
Yeah.
I think your net is not working right now because I am disconnected with you. I'm not able to connect with you. I'm sending you the connection request again if you are able to accept it.
Okay.
Or maybe you can close your AnyDesk again because it is showing me the network is resetted by the another computer.
Okay. I will
Okay.
again open any disk.
Yeah, and I will send you the connection request.
Yeah, I have opened
Okay.
830.
Yeah. Just a second. I'm sending you the connection request. Yeah, it is telling to me connection in progress. Please wait.
8309122.
Yeah. I send it you the connection request, but it is showing me
Yeah,
the
yeah.
same.
Yeah, I have accepted just now.
Huh. Okay. So now what I will do, I will show you if you will go inside your folder, right? Inside your output
Mm,
folder. Just
mm,
de novo RNA-seq folder. Here you can see it is the yeah. Here you can see that this assembly statics.txt file is here, right?
mm.
This file you have to open.
Open with text editor.
Open with the text editor. So now I will tell you how this assembly stats will work. Assembly stats, what it is doing, ma'am, it is taking the context. Context are what? Context are also the nucleotide sequences. Okay, that means how many number of the nucleotide sequences are able to make your complete assembled genome. Okay, so you can
Mm,
see that it is telling to you these many number of the nucleotide bases will be present there. Okay, what is the length of your largest contact? This is the length. But here you can see that this N50, N60, N70, what all these things, right? Maybe you are just thinking. So now let's
mm.
discuss what all these things are. So I will click here. I will go open the new tab and I will type down here 50 in genome assembly. So I'm going to explain you from this Wikipedia link. So what is this N50, ma'am? This N50 value is very important. Whenever you are going to go for any publication, you are going to go for any project, they will always ask you what is the your N50 value. Okay. Why this is important? N50 value is actually that value which is telling to you how many number of the contexts are able to cover the 50% of your reference genome. Okay, that means how many number of the shortest contexts. Okay, that means you can say that how many number of the contexts, that means with the shortest, with the largest numbers, right, but with the shortest length they are covering. Okay, now you can just read this thing till here and tell me what you are understanding from this thing.
Okay.
till
N50
maybe
statistic.
here, till this. Okay.
Okay. N50 statistic defines assembly quality in terms of content. Given a set of contexts, the N50 is defined as the sequence length of the shortest context at 50% of the total genome length. It can be thought of as the point of half of the mass of the distribution. The number of bases from all contexts longer than the N50 will be close to the number of bases from all contexts shorter than the N50. For example, consider 9 contexts with lengths 2, 3, 4, 5, 6, 7, 8, 9, and 10. Their sum is 54. Half of the sum is 27. The size of the genome also happens to be 54. 50% of this assembly would be 10 plus 9 plus 8 is equal to 27, half the length of the sequence. Thus N50 is 8, which is the size of the quantum, which along with the larger context contain half of sequence particular genome.
Hmm. So can you tell me what did you understanding from this?
From this, N50 means out of that genome, smaller size of quantity,
Mm-hmm.
which is we can say smaller, which
Uh-huh.
is going to cover all mm,
So
half
I
of the
will
sequence.
explain you. Okay. Some things maybe you are understood, some you are not able to understood clearly. So basically what they are telling to you, ma'am, they are telling to you you have these many number of the contacts. Okay. And if you will count how many number of the contacts these are the total 9 contacts, right? With
Mm,
the 2 nucleotide base pair, with the 3 nucleotide base pair, with the 4 likewise, right? And if I will add every contact, right, if I will add every nucleotide base pair of the contact, the sum of my nucleotide base pair is 54.
mm,
Okay. And the half of the 54 is 27. Okay. That means मेरे genome, what should be my genome size? It should be 54 nucleotide bases, right?
total.
Correct.
Mm,
Total 54 nucleotide base pairs should be there. Then it is telling to you what we are going to find out. We are going to find out how many sequentics, right? How many less number of the contexts, okay, able to cover my half of the reference genome. So obviously it is the larger context only, correct? So what it will do, it's going to take the last context, and it will try to check are those last large contexts are able to cover your 50% of the genome. Okay. So if you will see from here, what it will do, it will check 8 plus 9 plus 10, right? 8 plus
mm,
9 plus 10 is able to cover half of your reference genome, right? Because if you will
yes,
sum the 8, 9 and 10, it is again the 27.
yes,
Okay. That means what it is telling, it is going to be take 8 as a N50 value. Okay. Why it is going to be take 8 as a N50 value? Because 8 is actually that larger context which is coming with the another context, right, which is actually, you can say that, working as a bridge in between smallest context and larger context to cover your reference genome. So we can say that after 8, whatever context is going to be start, they are able to cover your complete reference genome. Okay. That is why here your N50 value is 8. Clear?
so we have to select that context which is in between smaller and
Right.
larger
Okay.
context from this.
Yeah, or you can say that with the help of which quantity you are able to cover the complete 50% of your reference genome. So this N50 value is always going to be changed, right? It is not same. Okay? Because
Yes.
always the quantic size is different. Hello?
Yes.
Yeah. Always the quantic size is different and on the basis of that it is going to be changed. So in this case, in our case what is happening? Our N50 value is 492. That means 492 nucleotide base pairs are there which is able to cover our half of the content. Okay,
Hmm.
with the half of the reference genome. But you can say that they are not giving you the half, actually they are also giving you the largest contig as well. Okay, what is the average length of the contig? That means for if they will sum each and every nucleotide base pair and they will take the sum for you, so this is the sum for you. Okay, and how many number of these sequences will be there? These many number of these sequences will be present. Okay, any nucleotide gap is there? No. Any n count? That means the when they are doing the assembly, the assembler is not able to detect any nucleotide base pair, so it is also 0. Any doubt or query, ma'am, here?
Yes. Here, sum means total number of here
Nucleotides,
with
ma'am.
overall, which is
Yeah,
present in that.
overall. Overall in your reference genome, ma'am.
Okay, overall nucleotides. Then this n is
N is the total number, right?
number of transcript. This small n is or
No, no, no. Just a second. I will show you. Please. So, see here actually they are explaining you the one output of the assembly steps, right? Here what they are
hmm,
telling to you, they are telling to you this is the sum. This means this is the sum of your total nucleotides. Okay,
hmm,
that's many. These many number of the nucleotides are present in your data. Okay, this is
yes.
what. This is the n. N is what? N is the total number of the contexts. Okay,
Okay.
what is this average? This is the average of your nucleotide bases. Okay, from the transcript. What is actually the largest quantic which is present in your assembled genome? So this is actually the largest quantic, ma'am, which is present in your assembled genome. Okay,
Hmm.
so you can see that here what they are telling to you. They are telling to you the number should be self-explanatory, except maybe the lines like N50, N equals to 5. So the N50 with 50% of the assembly with the 5 sequences. Okay. So here you can see that this is your total number of the bases, but these bases are actually having only the 5 sequences.
So five contigs are covering in.
Correct. 5 quantics are covering 50% of your assembly, right?
Hmm.
Fine. So yeah, then they are telling to you the same thing. You can see that just like our. N count and gaps, anything is there.
So
Maybe
N60 and 70.
these
These.
are the sequence, ma'am, right? That means how many sequence are able to cover your 70%, 80%, 90%,
Mm.
100%.
Mm.
Okay,
Yes.
now clear?
Yes.
Okay. So now what we are going to do, we create the we generate the statics of the assembly. After that, now what you have, if you will compare this, ma'am, with the reference based RNA-seq, right? In the reference
Mm.
based RNA-seq, what you have the assembled reference genome, or you are going to be map your raw data with the your reference genome, correct? Now here in the de novo, what we have, now we have our assembled genome, correct?
Mm.
We can also map our raw data with the assembled genome, right?
Yes.
So same thing what we are going to do, we are going to do generate, or we are going to be map our raw data with the help of the assembled genome. Fine. So what is
Yes.
our raw data? Our raw data is control 1 and treated 1, right?
Mm.
But
Mm.
for that what you will require, ma'am, you will require the RSEM, and RSEM is actually required the version of the R 3.6 or more than that. Okay.
Okay.
So here actually I gave you two links here. Okay, so maybe what you can do for requirement of the R version, right? For updating the R version, because if you will check, I will show you in your system it is R 3.4. We don't have R 3.6 in your system. Okay. So first
Mm.
what I have to do, first I have to update the R in your system. Okay. So for updating the R in your system, what I am going to do, I am going to use this link, or with the help of this link I am going to be update the R. Or maybe I can directly type here update the R version in Ubuntu. So see, it is also one link. Let's check they are giving you anything or not. Are you able to increase the size from somewhere? So you can see that first thing it is telling to you, you have to run this command in your system. Okay. So what I will do, I will copy this command and I will paste this command here, and we will execute this. Give your password. So it is executed. Okay. But before that, I wanted to show you, right? You can see that your R version is actually not updated till now. See, it is 3.4. Okay.
Mm.
After the execution of this command, what we have to do? Again you have to go with that server and we will copy this command. Okay, I will copy this command and again I will add this command into the terminal and enter. It is done. Then you can see that the next command which it is telling to you have to again run the command sudo apt install rbase. So I will again copy this and I will run this and enter. Right? And if I will type R here, it is R, it is telling to you why it is R again. Can you press the Control Z, ma'am? Okay, just a second. Okay, I think in your this command is not working. See, it is telling to you error unable to correct the
Okay.
problems. Okay,
Yes.
maybe just a second. Okay, so it is done. Now I will again check your R version.
It is again 3.4.
3.4. Okay, no problem. Control Z. Can you press the Control Z? Why my up arrow key is not working? Can you press the up arrow key, ma'am?
Mm.
Again, again, again. Yeah. One more time. No, no, no. One more time.
This.
Again, it is repeating. Okay, no problem. Wait. No problem. Okay, let me handle. Maybe I can go through with another link. Why? I don't know. It is not working in your system. Okay. So maybe I'm going with this link. This link will work for sure. Okay. So I'm just going to scroll this down here. So can you, what you have to do, I will guide you and you can copy paste it because I'm not able to do these things in your system. Okay. So basically what you have to do, first you have to copy this same command. So can you copy this same command? This.
Which command?
Can you scroll down little bit?
Mm.
Mm-hmm. Yeah, this sudo apt key. Go a little bit upside now.
This.
Yeah, sudo apt.
This
Yeah,
command.
yeah.
Whole. Okay.
The full
This whole
command.
command.
Right. Copy it, paste it into the terminal.
After this, or I have to delete this.
You just delete this, then paste it.
So for deleting,
Backspace you can press, right? One by one you have to.
okay, one by one. Delete key is not working.
No, no. Enter. In the meantime, it is executing. What you can do, just go with that website again. What you can do, ma'am, this part you have to copy, right? This slash etc app source list. Copy this.
Okay.
But before, yeah, copy it. Go with the terminal. But what you have to do, here you first type sudo gedit, space, now paste it. Again, this is a sensitive file, ma'am, which is going to be open. Okay, enter.
Yeah, it has.
Yeah, just go at the end of this page. Hmm.
Mm.
Scroll down, go at the end of the page.
Yeah.
Yeah, now what you can do, again go with the website page. Hmm. And here you there this 18.04, right? Because your system is 18.04. Copy this path.
Mm-hmm.
Hmm. Copied?
It's golden. Okay. Till here, slash, till here. Or
Yeah,
till
till it.
60.
No. Till slash only, ma'am. Copy. Now go with that file.
File, this file.
Yeah, this text file.
This. Yeah.
Hmm. Open.
Mm.
You are at the end of the page, right?
Yeah.
Just a second. Just leave the mouse for a second. Yeah, just paste it here. Now save this file and close this. Again go with the website page. Yeah, scroll this down. See, it is telling to you have to run the sudo apt get update.
Update.
Just run this command again.
So,
Get update and paste. Enter. Now ma'am just type capital R and check. It is 3.6. Okay. Again press the Control Z. Go with the website again. Copy this next command. Copy it. Paste it here. Enter. Our base depend on our base score 4.0, but okay, why it is doing this thing? Just a second. You have broken packages, it is telling to you. Just a second. Okay, a restart is required. Fine. Can you copy sudo apt-get install -f?
Yes.
Please copy it. Okay, no problem. Just a second, ma'am. Just leave the mouse. No problem. If this website is giving you the problem, we will shift to next one. Or I am just sharing with you one link. Just give me a minute. Okay. Mhm. So you don't have the Skype here, ma'am, right?
Yeah.
Okay, just a second. I will check the website. Digital Ocean. So what I'm going to do basically, I'm just going to close this thing here. Okay, I understand. I will open the new terminal here. So same thing, this is the first step and it is the actually same step. Okay, so you can copy this. Again go with the terminal, paste it here and run it here. And then
Oh.
it's sudo, ma'am.
Okay. S is not.
So maybe you can copy it again or just type S. Or anything you can do.
Yeah, I'm just trying to type S there, but it is or of that one. Mm. Okay.
enter. Hmm. Just go with the next command, ma'am.
Next one.
Hmm. See what 20 pages can be upgraded. Okay, done. Fine. Now next, go with the next command, ma'am. It is not throwing any error, right? Right.
Still same.
Why it is showing you this error? I don't understand. Just a second, okay? Maybe I will remove the RBs from your system then. Are you copying? And enter. Then what they are telling. Can you scroll down after this, see what it is telling to you, ma'am?
Mm.
Mm-hmm. Okay, just copy this sudo apt fix. Yeah,
Documents.
yeah. And enter. Done. Then go with the
Mm.
website again. Copy the next command, this one. Sudo apt dist upgrade. And enter. Press Y. And check in that website the next thing what they are telling to you. Can you check, ma'am, what the next thing they are telling to you?
Mm. Next command is, oh, it is,
What happened? You clicked somewhere?
no, I think, but it is shown. This is the same site, which yeah.
Mm-hmm.
We are done with previous. I think this command we are done. Next is
Okay.
this.
Can you check this bionic server command, please? Yeah. Just check which version of the R at the end they are providing to you.
This command, right?
Just copy it so I will see.
Mm.
Okay, this is again the older version and your system is showing the problem with this version. It is telling you have the 40 version. Okay. Just copy it. Hmm. Paste it here. Paste. Are you pasting? No, you didn't copy the complete command, right? Just leave the mouse for a second, okay?
No.
Okay, this command you have to add to your source list. Okay, just a second. What happened now? Mm-hmm. Go upwards, ma'am. Little bit more. No. I want that command where you are before.
Which command? This
Which one
command
you?
which we have copied now. This.
Yeah. So here you can copy this one. It's sorry, this etc, this app, this source list, right?
Mm-hmm.
Mm-hmm. Copy it. Hmm. Open the terminal here. Type here sudo gedit.
Sudo gedit.
Mm-hmm. Gedit space. Yeah, paste the path. Enter. Now scroll this down. There, yes, go at the end. Hmm. At the end, right? See what they are telling to you. They are telling to you just remove this 35 path from here because in your system you have 40 paths, right? And I think if you will go here, what they are showing you, this tab HTTP cloud and something. With the biocran 35, right? And your path is
40.
okay. Is it 40? I'm not able to see. Biocran 40, yeah. I just removed that one. Right. After that, just we will try to update it again. Okay.
Mm.
Enter. Done.
Yes.
Can be upgrade. Okay, maybe you can update that one also, ma'am, which is not upgradable. Okay, what is 16 package can be upgraded. Okay, fine. Then after that, what is the command which it is showing to you? You can go with the website, please check.
This rbase.
Please just run this again.
So copy this command.
Yeah, paste it.
Unable to correct problems.
Okay, no issues, ma'am. What I will do, I will install the RSIM if it is not able to correct this problem. I don't know why it is telling to you. I will check how to remove the RBS. Just a second, okay? If I am able to
Okay.
find out that command, I will share with you right now. Just give me a minute, okay? How to base from how to uninstall the R. What you can do, ma'am, you can just uninstall the R first, right? So I'm just copying the command for you and I'm sending it to you. Okay. First, what you can do, you can just remove the R. Okay. After removing this R, just type the capital R and check is it removed. Okay.
Hello.
These two
Yeah, what?
commands you have. Hello.
Hello.
Yeah. I shared with you two commands, right, ma'am? These two commands you have to run. Sudo apt-get hyphen hyphen purge.
Okay, on Skype you have shared.
Yeah, yeah.
Okay. Okay, first sudo app get purge remove rbase.
Yeah, so two time hyphen is there, okay. So you are not able to copy, ma'am, you have to type manually.
Okay, sudo app get purge remove rbase.
Sudo apt get space
Space double
hmm,
hyphen
hmm, purge hmm, space
purge remove
space remove r
space and then r, right? R
right, then dash base.
e
No, first base, ma'am, only.
first is base, right?
Remove the hyphen as well and enter.
Remove rbase. Yeah.
And enter. Yeah. Now run the second command, ma'am. So it is same, after the base you have to just add the dev,
So
right?
of arrow key I can press.
Yeah.
I can remove.
Hyphen. No, R
Just
base.
have to add base dev.
Yeah, dash dev and enter. Now press the capital R, ma'am, and enter. Why it is here? Okay, I will try to solve this error tomorrow. If it is not working, only one tool you have to run on my system. Okay, ma'am?
Okay.
Okay? Okay, ma'am. Then we will continue tomorrow. Okay, ma'am. Bye.
Bye bye.
And tomorrow also you can come early. Okay?
At 9.
At night. Fine.
Okay.